These two posts, just a few lines of text by two influential voices in the tech space, have ignited a storm of conversations. My social media feeds are buzzing, filled with commentary, debates, and threads that seem to extend endlessly. What's clear is this: they are an indication, a signal, an alarm that something has fundamentally shifted in the software industry. In a recent LinkedIn post, Amazon CEO Andy Jassy dropped a bombshell. Amazon Q, their generative AI assistant, has dramatically redefined what's possible in software development. Take this: what used to take 50 developer days to upgrade applications to Java 17 now take mere hours. The equivalent of 4,500 developer years of work saved, just like that. In less than 6 months, Amazon upgraded more than half of its production Java systems. A process that usually demands extensive time and resources was completed in a fraction of the time at a fraction of the cost. And the most striking part? 79% of the auto-generated code reviews were shipped by developers without any additional tweaks. The AI didn't just assist, it delivered. And it's not just the corporate giants making waves. Influential voices in AI research are also weighing in on the transformative power of AI in coding. In a recent tweet, AI researcher Andrei Karpathy shared his experience with AI-assisted programming. He found this tool so effective that they have completely reshaped his coding workflow. Karpathy describes a new way of coding, what he calls half coding. He writes prompts in plain English, reviews the AI-generated code divs, and lets the AI handle the heavy lifting, completing substantial portions of the code in record time. Karpathy says he can't imagine going back to the way things were. And neither can I. I've been using these code generators for over a year now, and my productivity has positively increased. So let's start with a fact. Coding is about to or is already undergoing a seismic shift. While I was researching about this topic, I stumbled across Russell Kaplan's thread on x.com, which resonated well with me. Russell Kaplan is former Tesla engineer as well as a Stanford AI researcher. It's a fascinating thread, so I'll break down some of the tweets that were thought-provoking. Here's why this matters. Research labs around the world are pouring resources into making AI models better at coding and reasoning. This isn't just incremental progress, it's a massive leap forward. These models are being trained to write code, reason through problems, and improve themselves in ways we haven't seen before. Why coding? What makes it so special? The answer lies in the unique advantage coding offers. It's a domain where AI can learn through self-play. Unlike other fields where data is limited by human expertise, code can be tested, tweaked, and optimized automatically. It's a playground for AI, where models can write code, run it, and check for consistency, all without human intervention. This kind of automatic supervision is not just beneficial, it's revolutionary. But what is self-play? To understand self-play, let's learn about the model that pioneered the concept itself. AlphaGo, developed by DeepMind, is a groundbreaking AI that made history by defeating human world champions in the ancient game of Go. One of its key innovations was the use of self-play, where AlphaGo played countless games against versions of itself. This technique allowed the AI to continuously improve, discovering new strategies and refining its decision-making process without human input.
When we played against Lee Sedol, we actually had a system that had been trained on human data, on all of the millions of games that had been played by human experts. We eventually found a new algorithm, a much more elegant approach to the whole system, which actually stripped out all of the human knowledge and just started completely from scratch. Instead of learning from human data, it learned from its own games, and that became a project which we called AlphaZero. Zero meaning having zero human knowledge in the loop.
Fascinating, isn't it? Using this as inspiration, researchers from Microsoft and MIT in the paper "Language Models Can Teach Themselves to Program Better" demonstrated an answer to the question: can a language model design its own programming problems to improve its problem-solving ability? Rather than using English problem descriptions, which are ambiguous and hard to verify, they generated puzzles. The result? The diagram illustrates how the iterative process of generating, verifying, and fine-tuning on the synthetic data significantly improves the performance of the large language model in solving puzzles. Now let's look ahead. In just a few years, software engineering will be almost unrecognizable. Imagine having an army of coding agents at your disposal, each one capable of handling tasks from start to finish. This isn't science fiction, it's where we are headed. Engineers will transition from writing lines of code to managing these agents, overseeing the architecture of systems and making high-level decisions. This shift will redefine the role of the software engineer. In the new world, coding becomes less about syntax and more about strategy, understanding what needs to be built and why. It's like moving from being a craftsman to a project manager where your focus is on the bigger picture. To extend this idea, I return to Andre Karpathy's vision of AI resembling an operating system, essentially a powerful agent. Andre describes this as an entity with more knowledge than any single human on all subjects. Now imagine this as a specialized agent focused on a specific domain or a business use case. It's possible, and we may not be very far from it. Russell calls this software abundance. As coding becomes 10 times more accessible, we'll see a proliferation of what can be called as single-use software, apps and websites designed for specific, often one-off purposes. This abundance won't just democratize software creation, it'll fundamentally change how we think about software itself. As this new reality unfolds, the role of the software engineer will continue to evolve. Just as engineers transition from assembly language to high-level language like Python, they will adapt to a world where English rather than code becomes the primary tool of communication. This challenge will require a shift in mindset from focusing on how to write code to understanding what needs to be accomplished. We are on the brink of transformation that will not only change how we code but also how we think about building software altogether. And what can help navigate the ambiguities during this phase is adaptability. If you're excited about this future, as I am, hit the subscribe button to stay adaptable to the new possibilities. Leave a comment below on how do you think AI will change the way you work or build.